Hi, today we're going to talk about linear piecewise functions. This is a graph of a linear piecewise function, and you'll find it on page 7 of your journal. We're going to go through and talk about the answers to the questions there. So the first thing it asks is, does this graph represent a function? So remember, the rules of a function are each x has only one y, and we can also test it using the vertical line test. So by doing that, we can see that yes, it is a function because no vertical line can be drawn through more than one point on the graph. Then it says, what is the value of the function when x equals 0? Well, I look at x equals 0 and I see that the value of the function is 0. So that is where it's plotted. Okay, now they want you to write an equation that represents the values of the function when x is less than or equal to 0. So I look at this graph because that's what they're asking me to do, and I'm just going to think of the slope-intercept form of a line. And I can see that my y-intercept is 0. I can see that I have a negative slope, and then I look at my slope and I go up 1 over 1. The slope is negative 1. Don't forget your x. So if I'm going to plug that in here, I would write y equals negative x. Or in function form, it would look like that. Then in D, they're asking you what is the equation that represents the values when x is greater than but not equal to 0. So we see right here, that's how they show us not equal to. And this is a horizontal line, and it's y equals 2. So that's what I'm going to put in for the function. When you combine them, you get the equation of the linear piecewise function. Notice they only write the f of x once, then they write equal, and then they put a bracket. Then they list each of the equations. So this is the y equals part, and this is the mx plus b part of the equation. This represents the domain, which tells you that this equation only applies if this is true, and the bottom equation only applies if this is true. So let's look at more examples. Okay, for this one they're asking you to graph. So you've got each equation and you've got the domain that goes with it. Here is your definition of a linear piecewise function. It's defined by 2 or more equations. Each piece of the function applies to a different part of the domain. So if I want to graph it, the first thing I'm going to do is separate my equations and graph them. So I look at this one. Again, I'm going to think of y equals mx plus b. If you need to make a t-chart, you can, but it's easier if you learn to graph this way. So I'm going to mark my intercept, my y-intercept, which is negative 2. Notice I'm not putting closed circles right now because I haven't looked at my domain. Then I look at my slope. My slope is 1. So that means I just go up 1 over 1, make a line, point, and I just keep going. Now that I've got 3 points, I'm going to go look at my domain. And I go, oh, this is only part of my graph when x is less than or equal to 0. So here is x is equal to 0. Then I'm going to make a point here, and I'm going to make a point here to continue my graph. And if I wanted to draw it, it would look like that. So then I'm going to do the second equation, y equals 2x plus 1. I'm going to make a circle at my y-intercept, which is 1. And I'm going to do a slope of up 2 over 1. Because when I have a slope of 2, that just means up 2 over 1. So I've got a couple points there. And then I check my domain. And it's when x is greater than but not equal to, so that's going to be an open circle. And I'm going to graph it, and it looks like that. So that is the graph of your linear piecewise function with this. Okay, this is a step function, and they call it that because it looks like steps. So we're going to look at the different rules of this. What is the significance of the closed endpoint? We already learned that means that x is equal to that point, okay, in the domain. And the significance of the open endpoint means the domain does not apply there. So it's not equal at that point. It's either less than or greater than. So now they want you to look at figure 1. That's this one. Is this a function? think back to the rule, every x can only have one y. And so I can see that no, this is not a function because it doesn't pass the vertical line test. Look at figure 2. Is it a function? And you can look at every x and it only has one y, so this is a function. And the same is true of figure 3. So now that we've got an idea about step functions, we're going to go to problem exploration 2, and we're going to look at this one. Now notice that step functions are always dealing with a horizontal line. So that means that we don't have an x in this portion because a horizontal line, for example, this one would be y equals -2. There's no x involved. So if I'm looking at this one and I look at the portion, look at my domain, and that's this part. So y equals -2. Okay, I just figured that out. So look at each portion, pause if you want to and see if you can finish this, but you can get each portion of the graph, and this is what you should get. Okay, now I found this one in my old book, and it's asking you, is this a step function? And why or why not? So the first thing I notice is that it's all percentages, so it's going to be 0.01 for the first one. But is it just 0.01? No, it's for incomes. That is your x. So my first equation is going to be this, which means it's not a horizontal line. So if you wanted to see what this one looks like, this is what your step function looks like, and this is the graph. Is it a function? Yes, because every x has only one y. Because people that earn this much only get this tax rate. People that earn this much only get this tax rate. People that earn over $7,000 are taxed at this rate, which, ask your parents, that's a really good state tax bracket. Okay? All right, then in the extra practice on page 10, they give you a bunch of problems and they ask you to do something. They say evaluate the function. Well, they're asking you to evaluate it for this specific value. So for number 1, they're saying when x equals 0. So first thing you have to ask yourself is it from the f of x or the g of x? Because they gave us two different equations. Well, since this one says f, I know that it's from the f of x. Okay? Then it says what part of the piecewise is the x from? So now I'm going to look at my domain and find where 0 fits in. So I can see that 0 fits in here where x is less than 0. And now I'm going to plug the constant in for the x and get the appropriate answer. So I'm going to go the f, or I'm going to go 3 times, plug your x in, minus 1. So 0 minus 1 is -1, and that represents the point 0, -1. So now look at number 9, and it's saying use the g function. And now we want to know where is -5. Well, that happens to be the first one again. So I go 3 times -5 minus 1. So that's -15 minus 1 is -16. That's the value of my function here. So you could write it like this. If they wanted the point, it would be -5, -16, because this is your x. Okay, so now after I've done that explanation, after I show you what you're going to do, you're going to pause here and you're going to do all of these problems. 15 is optional. So when you're done with these problems, then you can unpause the video. Okay, so here are the answers for 2 through 14 even, and 15 if you wanted to do that. So pause here and check your answers. If you got them right, then you can keep going. If you didn't, circle them so you know which ones to come back to. Okay, so this is the end of this PowerPoint, and I'm going to go on to explain the rest of the answers. So the first thing I'm going to look at for number 2 on the ones that were assigned is that I'm looking at this function, okay, and I'm looking at x equals 1. So I have to look at the domain, when does x equal 1, and that applies to this function. So I plug the 1 in, 3x, 3 times 1 minus 1, 3 minus 1 is 2. Okay, for this one, when does x equal negative 4? Again, it's going to be this one. So I plug that into the top equation. 3 times negative 4 minus 1 is negative 12 minus 1 is negative 13. Now I'm moving to the x function, and I look at the g function, sorry, and where does that in the domain equal negative 3? So I can see that applies here. So I'm going to go 3 times negative 3, which is negative 9, minus 1 is negative 10. Now for this one, it's saying x is 3. So that doesn't fit here, but it fits here. So now I'm going to use this equation. So I go negative 3 times 3, and that equals negative 9. Okay, the next one is drawing the graph. So I'm going to look at each graph separately. Y equals negative 4x. I can see that my y-intercept is 0. And if I was normally graphing, I would just go down 4, 1, 2, 3, 4, and it's negative, so I'm going to go back 1. So that would be right here. But then I've got to look at my domain, and I see that, oh, it's only when x is greater or less than or equal to 0. So now I've got to go backwards. I'm going to go up, 2, 3, 4, and back. And that becomes my next point. We see that the domain is x is less than, so this should be a solid line. And you can see by the line, that's the one I just graphed. The next one is y equals 4, and right away I see that that's a horizontal line, and it only applies when x doesn't equal 0. So I've got an open circle. For number 11, I have 3 different equations. So my first equation, y equals 2x, I'm going to graph. So I have a open circle at the 0, 0 because I have a 0 y-intercept. My slope is up 2 over 1. And then I stop and look at the domain, and it only applies when x is less than negative 2. So right here is negative 2. So now I'm going to go down 2 over 2, like that, and down 2 over 2. And I can see that it's not equal to negative 2, so I have an open circle here. And then I'm going to go down 2 over 2, or if you used a t-chart, that's where you would apply it. The middle one, which is between negative 2 and it's equal to, and positive 2, but it's not equal to, is a horizontal line, y equals 2. And oops, that one's down too far. That should be up there. So if you got that one right, good for you. I boo-booed on that one, so that's what it should look like. Okay, so this is wrong. This is the correct graph. All right, and then the next one, y equals negative 2x. I can apply that again. Going to graph it the same way I did before. So y equals negative 2x. And I could make a quick t-chart, and I'm going to start with just 2 and 3 and 4. So negative 2 times 2 is 4, and that gives me the point 2, 4, which is right there. And then negative 2 times 3 is 6, and that gives me that point there. So I'm ready to go. See, even teachers make mistakes. Oops. Okay, on this one, we're going to figure out what each equation is. So again, I'm going to use y equals mx plus b. This one is really easy because I can see that it's y equals 3. And I can see that it only applies when x is greater than or equal to 0. So I got that equation right there. This next part only works for for x is less than 0. So I could go ahead and write my domain because I can see it right here. The next thing I'm going to do, I see my y-intercept is 0, and it's a negative slope. So now I just have to figure out my slope. So I have this point, and I'm going to go to my next point that covers a line. And it's not until up here. So what I'm going to do is I'm going to count. My rise is 1, 2, 3, 4, 5, 6, 7. So it's 7. And my run was 1, 2, 3, 4, 5. So that's how I got the slope for that one. And that gives me that equation. Okay, for number 15, I have two horizontal lines. So those are quick and easy. I have y equals 3. And that only applies between these two values. Negative 3, where it's x is equal to that, and 0, but it's not equal to that, so it's less than. Then I have y equals 4 right here, and it's equal to 0 and equal to 1. So that gives me that domain. And then the next one I have to figure out. So what I did was I'm going to look at y equals mx plus b, and I have to figure out my y-intercept. So I start here and I go down 1 over 1, down 1 over 1, down 1 over 1. Ah, it has a 0 for the y-intercept. I can see that my slope is 1, and it's positive, so that gives me that equation. Notice on this one they put 1 instead of the f of x, and that's okay unless they ask for it in function form. Notice, be very careful, this function stopped at 5, so you want to put that. If it didn't stop at 5, if it was a line going straight up, then it would be, if it was a continuing line, then your domain would be x is greater than 1. But this one is limited by the diagram, the graph, so you're going to have to put the ending point. And that's it. Good luck with your homework.